So hello everybody, today I will be doing the EIEIO project. First we will start with the problem, because everything starts with a problem, right? So the problem goes, Mr. Rainville had a farm, EIEIO, and on this farm he built a fence, EIEIO. He wants a rectangle here with 120 meters of wire there. With this information we are given two different parts to the problem, the first being what are the dimensions that Mr. Rainville should use to have the maximum possible fenced-in area? The second part being the maximum area if he used this one side of his barn to replace one side of fencing. So with that, we can begin on the first portion of the problem. How will we find what the most wire-efficient rectangle we can make is? Well, I employed the strategy of starting with the easy-to-calculate square. This is because all the sides are the same, so all we have to do is take 120 meters of wire and divide it by 4. With that we come up with 4 sides of equal lengths of 30. Using the area formula for a square, s squared, we get a total area of 900 square meters. And with that we have a pretty good baseline to base our next results off of. Next, to test further which rectangular shape is the most efficient for area, we will offset this perfect 30 by 5 and 10 meters respectively. So for rectangles, area is length times width, so 25 times 35 meters equals 875 meters, a total of 25 meters less than the square. 20 times 40 is 800 meters, a full 100 meters smaller than the square's value. A pattern is starting to emerge, but just to confirm it, let's go to the extreme, a 25 meter offset. 5 times 45 comes out to be 275 meters and proves this pattern. The further from a perfect square Mr. Rainville is, the less amount of total area he is going to have. However, let's see if the second portion changes this perfect square. In the spirit of last time, we're going to gear for another perfect square right off the bat, that is assuming the length of the barn to be 40 meters. Reason being was that instead of 120 divided by 4, I calculated 120 divided by 3 for the side of the barn was covered. With that, the area of the square fence comes out to be 1600 square meters. By adding the side of the barn, Mr. Rainville would have gained at least 800 square meters. That's the area of approximately 3 tennis courts he gained, just by using the side of his barn. However, to see if this barn side finishes a square being the most area, we must use offset again. Now this time, offsetting will not be as simple, and we will have to assume different barn lengths. Reason being, opposite sides of a rectangle must be the same length. And then, you are left with 80 meters for the other two sides. 40 becomes the only remaining option. So with that, let's calculate the offsets, 5 meters and 10 meters again. 35 times 45 comes out to be 1,575 meters, a decrease of again 25 meters. 30 times 50 comes out to be 1,500 meters, a decrease of 100 meters. It comes out to be the same reduction from the perfect square, only the areas are significantly larger. Testing the maximum offset possible, an offset of 35 meters, we get 375 square meters, very far from the 1,600. With that, we can conclude that using a perfect square nets more area than using a rectangle. This problem is a good problem because it has its roots in everyday life. Indeed, even if you weren't going to be a farmer, fencing is used often by the common people. It can be used for keeping your pets in and neighbors/uninvited guests out. The change from part 1 to part 2 is very informative to this, as it increases the amount of area with the same amount of materials. It is very neat to know that quartering your sides can end up doubling your area, so remember this folks, if you got some fencing that you need done, having your house take a side is the most economical by far.